Hello everyone, welcome to Code is Good. In this video, we'll look into what is counting sort, how does it work, and we'll have a sample code which will demonstrate the sorting using counting algorithm. Counting algorithm is a sorting algorithm which takes an array of numbers to be sorted, and it provides a result in which the numbers which are given for the input has been placed in the sorted order. While doing its algorithm, it makes few assumptions about the data that comes as part of the input, the the one that comes as part of input. It does some assumption related to the data, and based on that assumption only, it applies its algorithm. So its assumptions are that it works only for the non-negative discrete values provided in the input array. It doesn't work with floats and strings. And this value, like whatever input array that you have been given with to sort, so all these values inside that, suppose 2, 4, 9, 10, 6, whatever numbers are there in the array, they should be in a reasonable range, that it should have a starting number and an end number, and those two difference, the minimum number in the array and the maximum number in the array, they should be in a reasonable range. Range means 1 to 10, 11 to 15, like this. It should be in a range. And one big advantage of this sorting using counting algorithm is that it doesn't make any comparison, like we see in the insertion sort, merge sort, quick sort. Everywhere we do the comparison, but in counting sort we do not need to do any comparisons. So how it works, like it whatever the input has come, it counts the number of occurrences of each of the numbers. We'll demonstrate this in an example which will make it more evident. So suppose over here, if we have got input number to be sorted is 2, 5, 9, 8, 2, 8, 7, 10, 4, 3. So if we have to sort this using counting sort algorithm, then firstly, the assumption we'll remember that it should be non-negative discrete values, which we see that it's not non-negative. Plus all the numbers, the minimum and the maximum, it should be in a reasonable range. So we see that in this entire array, the minimum number is 2 and the maximum is 10. So we create a temporary counting array in our problem, in our solution, which will be able to accommodate all the numbers by their index. Which means, suppose if I take this, we see that it lies from 2 to 10. So we will have another suppose counting array we have created, and its size is from 1 to 10. It's able to accommodate numbers from 1 to 10. Means 10 index array we have to create. And if we start the index by 1, it will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we have started by 1, so that it will accommodate all the numbers, that's why it has started by 1. Whereas its length will um, remain in between the minimum, the starting of it, and the max of it. So starting, since there are, we need a 10 number, so if we keep 10 as the last number, we have to start the array from 1. So after we have created a temporary counting array, then we will iterate this input array, and we'll place it into its respective position. Suppose we start with 2. So whenever we at the index 2 over here, which will be actually index 2 minus 1, and will increment it by 1. Then it is 5. The 5 will also be a initialized with 1. Ideally, we know that as soon as we'll create this array, all the index will have 0 value. So we are just incrementing it by 1 as soon as we are finding any number. So another is 9. The 9 also will increment. Then we have 8. Then we have 2, and over 2 we see that we already have placed 1 over there. So we'll increment it by 1 and make it 2. Then we have 8. 8 also we already had, so we'll increment it by 1 again because 2 occurrences have been found. Then 7, 1, 10, 1, 4, and 3. So in this way we were able to put the occurrences of each of the numbers in the input array into the counting array. In the final step, what we'll do that to the input array, which was having the numbers to be sorted in as an input, in that array we will start putting the number of occurrences of each of the numbers. So we'll start with 0. We'll iterate this array. We'll start with 0, and we see that over 0 we don't have anything. We'll move it to the next index. Over here we see that we have 2 2s, so we will write 2 over here. Then we'll move to next. Then we have 1 3. We'll write 1 4, 1 5, and we do not have any 6, so we'll skip 6. Then 7, we have 1 7. Then we have 2 8s. This is 8 8. Then we have 1 9, which will become here over here. Then 10 1. So if you observe right now, we have got the input array sorted over here. This is the working, that how using counting sort we were able to sort the input array. Let's go into our IDE and do the code for counting sort. So over here we have a driver method, main method, which has an input array, the example that we just saw some time back, and we'll call a counting array method with the input array, and min and the max. Min and the max is the range in which all the numbers should fall. So over here, let's start with the implementation. So firstly, we have to create an counting array, a temp array, in which we will be saving the counting of each of the occurrences of the numbers in the input array. We'll name it as input counting array, and its size will be max minus min and plus 1. Then we will iterate all the items in the input array to find the occurrence of each of the elements. For that, let's get the number in a variable, and then put it into the counting array. The index of it will be the number minus 1. We had seen that the number 2, the first number, was going to the 1th index of the array, because array starts with 0 index. So we have put it minus 1. And its value will be, if it is already there, then we'll take that number and then add by 1. In the beginning, when none of the occurrences would have been found, then this will be 0. In that way, it will be 1. Then let's take a counter then. This counter we have taken to iterate into the input array while we'll be doing the final substitution of the sorted elements. So this will keep a track of the index till we have done the sorting. Then let's take a for, and then it will go till the counting array. So next, take the number from the counting array and then we'll take another for loop, which will be for taking the number from the counting array and then multiplying it to its number of occurrences. So this will be our number of times it has come, and then we will substitute it in the main input array, which will be counter. We have already taken the counter, and it will be I plus 1. Then we'll increment the counter. So this is the implementation of the counting sort. Let's run it and check if we have written the code without any error. Okay, so here it goes. So this was the input array, and the output is 2, 2, 3, 4, 5, 7, 8, 8, 9, 10. It's sorted. So while we were doing the implementation and going through the logic of counting sort, we saw that it's not an in-place algorithm because we had to take a counting array for storing the number of occurrences of each of the elements in the given array. And also its time complexity is big O of n because we did not had to iterate multiple times in one iteration of the input array. We were able to get the sorting done in linear time. And this is all because we had made some assumptions about the elements to be sorted. That has helped us in getting the linear time complexity solution. Thank you for watching the video. Please subscribe to Code is Good. Thank you.